Hello everyone, welcome back to the channel. Today we are exploring a powerful tool for tracking system calls as Strace. So using as Strace is pretty simple. If it's not already installed, you can install it using a package manager. For example, on a Red Hat Linux system, you can use sudo yum y install as Strace. Now once a Strace is installed, to trace the system calls made by a program, simply run Strace and the program name. So for example, if I want to trace system calls made by the ls command, I can simply run strace ls. We are going to go in depth into what exactly these fields mean. As you can see, a strace will display a detailed list of system calls made by the ls command, including the parameters and return values. Let's see how it all works. So in the above case, when you run strace ls, the strace starts the ls command and begins intercepting and recording the system calls. Let's understand this further. When you execute this program, Strace provides you with a detailed list of system calls made by the ls command, including the parameters and return values. So the first thing Strace is going to do is execute the initial system call like execve. This system call executes the program. Let me rephrase, ls makes an initial system call like execve, which executes the program, and another system call called openat or open to open the directories. It also uses another system call called getIns to read the content of the directory. There are some other system calls made in this whole process. For example, the write system call, which is used to display the directory content to the terminal. And finally, once the ls command stops executing or is complete, it makes an exit system call. So let's understand this with a scenario and take an example of a simple script which I can show you. This script will read from a configuration file, but as you can see, the configuration file I have provided here is just a dummy path, and this path does not exist. So how can we use strace to debug this kind of issue? Let me execute the script and show you. Since this path does not exist, this script is going to fail. The first thing we are going to do is execute strace and save the output in a file called strace_output.txt. Strace stores the output, and the output you saw earlier on the screen is in this file. As you can see, the whole output is stored in this file. Now, in the next step, we are going to filter this output with a system call called newfstatat. So we are examining the output by further filtering with the system call, which is used to get the status of a file. If you scroll down, you will see something like this. Let's copy this output and understand it step by step. As I mentioned earlier, what we are doing at this step is breaking down the output to understand what exactly it is telling us. newfstatat is used to get the status of a file. The first argument at _fdcwd tells the system to use the current working directory as the reference point. So this is the current directory. It finds out that this path does not exist. In actuality, it is the path name of a file whose status is being checked. This is an absolute path we are specifying, but it can be a relative path. The next thing is this hexadecimal code, which is a pointer to a buffer where the stat structure is stored. The stat structure can store file permissions, file size, and timestamps of that file. All this information is stored in the stat or a pointer to a buffer. The next value is 0, which means no special flag is used. There are special flags you can use to modify the behavior of your system call. For example, if you use a symlink nofollow special flag, it tells the system call not to follow any symbolic links. If there are symbolic links in that directory or path, the system call will not follow those paths. One is the error code, which means an error. Enode stands for error no entry, meaning no such file or directory exists. To resolve this issue, check if the path you are specifying is correct or if the file exists and the program has the necessary permission to read the file. These debugging steps can help resolve the issue, except for Enode, which I mentioned earlier. There are some common errors like exe is permission denied, meaning the program or process does not have the required permission. Exists stands for file exists, meaning the file already exists. Einval stands for invalid argument, meaning the argument you are passing to a system call is not valid. If you are interested in checking for all the other errors, you can check the documentation. I will attach this documentation link in the video description. So far, we have seen that strace provides very detailed information about every system call made by a program. This is invaluable for debugging and understanding program behavior at a very low level. However, it can significantly slow down a program and expose sensitive information, so be very careful while using Strace in a production environment. Let's see some of the limitations of the Strace program and when not to use Strace. First is performance impact. Strace can significantly slow down a program because it intercepts and logs every system call. In a production environment, this overhead may lead to a performance impact which is not acceptable for production problems. Second is security concerns. Using strace in a production server can expose sensitive information, such as file paths, environment variables, and network addresses. These details are logged, which can be a security risk if the logs are not properly secured. Third is low latency applications. Using strace can add additional latency, which can be problematic for applications that require strict timing constraints. Although strace is excellent for system call level debugging, it does not provide high level application logic or user space code execution details. For complete debugging, use it in conjunction with other tools like GDB or performance profilers. Strace is a powerful tool for debugging and understanding system-level interactions of applications. It provides detailed insights into system calls, helping diagnose a wide range of issues from file access problems to performance bottlenecks. However, be aware of its limitations and potential downsides, such as performance impact and security risks, and use it carefully, especially in production environments. Thank you for watching this video. If you find it useful, please like and subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview. The link is in the description below. See you in the next video. Thank you.